Namaskar, warm greetings from DELNET Developing Library Network, New Delhi, India. The most esteemed speaker, Dr. Venketeswara IR, the Associate Professor, Department of Humanities and Social Sciences, Indian Institute of Science Education and Research, ISSER, Pune. DELNET officials, including Shri K. Jayakumar, President, Dr. S.S. Murthy, Vice President, Dr. P.R. Goswami, Treasurer, the heads of institutions, deans, eminent librarians, library and information science professionals, heads of departments, professionals from IKS centers established across India, faculty, researchers, scholars, and students, my colleagues here at DELNET New Delhi and also its coordination unit at Pune and Bangalore, ladies and gentlemen. I, Dr. Sangeeta Kaul, Director DELNET, on behalf of DELNET, extends a very warm, profound pleasure in welcoming you to today's inaugural webinar session on a newly launched DELNET Indian Knowledge Systems webinar lecture series, Wisdom of the Past for Shaping the Future. We are extremely honored to have with us today the distinguished speaker, Dr. Venketeswara Pai, Associate Professor at ISSER Pune, who will be sharing his vast knowledge on Indian contributions to the world of mathematics and astronomy. We are much appreciative of an overwhelming response to the webinar session, as more than 1,100 participants have registered from different parts of India and many other countries, including Bhutan, Nepal, UAE, and Sri Lanka. At the very outset, on behalf of DELNET, we would like to express our very warm, sincere gratitude and thanks to our esteemed speaker, Dr. Venketeswara Pai, for acceding to our request to be there with us this afternoon and to share his vast expertise with us. We are extremely honored to have you with us, Dr. Roy, and thank you so very much for being there with us. We are pleased to inform you that DELNET has launched a new webinar series today on Indian knowledge systems, which is devoted to capturing the rich intellectual heritage comprising sophisticated systems of knowledge that span across diverse disciplines, including architecture, art, astronomy, education, language, literature, mathematics, medicine, philosophy, science, and many others. This IKS webinar series from DELNET is an initiative to rediscover, celebrate, and critically engage with the richness of India's indigenous knowledge traditions. The eminent experts of IKS will be sharing their vast wisdom through this platform. As we move towards organizing the inaugural webinar session on Indian contributions to the world of mathematics and astronomy, let us also pay our respectful homage and remembrance to the renowned ancient Indian gurus and knowledge experts who made profound contributions to the field of mathematics and astronomy. We are reminded of Aryabhat, who is considered the father of Indian mathematics, and Brahmagupta, known for introducing zero as a number. Other prominent mathematicians, including Bhaskara I, Mahavira, and Bhaskara II, Srinivas Ramanujan, each contributing significantly to the field. Ancient Indian astronomy boasts a rich history with contributions from notable figures like Aryabhat, Varamik Mihra, and Brahmagupta. It is a profound privilege for me now to introduce our distinguished speaker, Dr. Venketeswara R. Pai, an Associate Professor at the Department of Humanities and Social Sciences at ISSER Pune. Dr. Pai's area of specializations includes Indian knowledge systems, history and development of astronomy and mathematics in India, history and development of Vakya system of astronomy, Kerala School of Astronomy, manuscriptology, scientific literature in Sanskrit and Malayalam, Paninian grammar. By training, he is a physicist and has a strong command in technical Sanskrit and Malayalam languages. Dr. Pai has received a PhD in the history of astronomy in 2011 from the Department of HSS at IIT Mumbai. Dr. Venketeswara Pai is also among a unique group of Indian scholars, researchers, and educators who have expertise in Sanskrit, mathematics, and astronomy. His research focuses on discovering the work of Kerala School of Astronomy and Mathematics in particular, and understanding the development of mathematical ideas and astronomical models in the Indian subcontinent in general. Dr. Pai uses source materials in the form of palm leaf paper manuscripts documented in Sanskrit and Malayalam in the area of mathematical astronomy. His research is multidisciplinary in nature and involves languages such as Sanskrit and Malayalam and fundamental areas of science areas such as astronomy and mathematics. I'm very pleased and honored to inform you all that Dr. Pai has been bestowed with a number of awards and recognitions, including Satish Bhattakar Award of 2024 by Indian Mathematical Society, Mahakavi Kalidas Sanskriti National Award in 2022, Mahadev Mathematics Award, Mathematics Award in 2018, ISSER Medal for Young Historian of Science 2015, and many others. Dr. Pai also serves as an advisory board member of various major universities and institutions. He has to his credit numerous publications comprising a book chapters, and many articles published in the reputed national and international journals. May I now have a pleasure of requesting our most esteemed speaker to kindly deliver the inaugural webinar session of the DELNET IKS webinar lecture series on Indian contributions to the world of mathematics and astronomy. Once again, a very hearty welcome to you, Dr. Pai, and we are indeed so much honored and glad, that you have been able to be there with us and agreed to share your vast expertise with us. Over to you.
Yeah, thank you, Dr. Sangeeta Kaul, for wonderful introduction, and good afternoon, you all. Good afternoon, you all.
I just request you, yeah.
Yeah. Okay. So, and I'm honored to be the first speaker or the inaugural speaker for this IKS webinar series. And I'm really grateful to the organizers, especially Dr. Sangeeta Kaul, for giving me an opportunity. So let me share the slide. Yeah. Okay. I hope the slide is visible. Yeah.
Yes,
okay.
Very much.
Yeah. So the broad topic that is given as the Indian contribution to astronomy and mathematics. So I have revised the topic as, the understanding mathematics and astronomy through Sanskrit texts. The reason is when we talk about the contributions of astronomy and mathematics in Indian context, the language Sanskrit the involvement of Sanskrit language is very much important, because most of the Indian traditional knowledge system or the texts are documented mostly in Sanskrit language. Of course, there are some texts which are in regional languages as well, but majority of the texts are in Sanskrit language. So the more focused title of the talk is Understanding Mathematics and Astronomy through Sanskrit texts. In this particular talk, we will be discussing how the Sanskrit as a language is used to represent several mathematical ideas, mathematical tools, and astronomical models represented through Sanskrit language. Okay, so now why mathematics and astronomy? Because astronomy, in Indian context, the mathematics got developed to facilitate astronomical computations, and without mathematics, one cannot do astronomy, which is known as mathematical astronomy in Indian context. And again, these are expressed in terms of Sanskrit verses. When I say verse, it's in Sanskrit is known as shlokaha, or in shlok in Hindi. So this is how a typical verse looks like. Okay, this is how a typical verse looks like. Vyase varidhinihate rupahrate vyasasagarabhihate trisharadi vishama sankhya bhaktam Ranam swam prathak kramat kuryat. This is a typical verse, the typical mathematical idea which is expressed typically in the form of a verse. Okay, so we will see the details of this verse later. Before that, I would like to give a brief historical background. When we talk about Sanskrit, so we have to go back to Vedas. Vedas are the earliest literature that is available in Sanskrit, and mathematics known as Ganitam and Jyotisham as astronomy as part of Vedas, in the sense the auxiliary text known as Vedangas. In the Vedic period, which is historically, several scholars in historians have placed Vedas and Vedangas approximately from 14th century BCE to 40th century BCE, where Vedanga Jyotisha and mathematics, that is Ganita, also part of it. When we talk about Ganita, especially the geometrical aspects of mathematics is dealt in Vedangas, especially the text known as Shilpa Sutras. Here in this particular picture, you can see a ritual. So this is particularly developed in the context of cultural context or the religious context. You can see a picture of doing Havana, where you can see a simplest geometrical figure, which is a square. So when we talk about the texts known as Shilpa Sutras, we have more complicated figures like this. So this is when you look at this figure, you can see that this is like a falcon, okay, and this is called falcon-shaped altar, okay. When I say altar, it means homakunda. So it's a large shaped. The size of the altar is very big, and this is known as Shena Chitihi. Shena is Sanskrit term for falcon, or and the Chitihi is the kunda kind of thing. Okay, and this the homa or havana is done on top of it. Okay, this form the base of the ritual that will be happening. So now if you see, this is a very complicated structure where you have trapezium, triangles, like isosceles triangles, squares, rectangles, and right angle triangles, and they are arranged in a particular size and shapes. So where the knowledge of geometry come into picture. Okay, so I'm just giving a brief idea how the mathematics in Vedic period, that is geometry, especially geometry, in the context of Shilpa Sutras, in the context of rituals, how it got evolved. Okay, so but today's my main focus would be after 4th century CE. Okay, when I say after 4th century CE, Dr. Kaul has already talked about Aryabhata. Aryabhata is an astronomer who has composed a text known as Aryabhatiya, and such kind of text are known as Siddhantic text. It comes under the class of Siddhantic texts. So when we talk about astronomical literature, Indian astronomical literature, which are in Sanskrit, it can be classified into two subcategories. One is Siddhantas, and the earliest Siddhantas that we can trace back is Aryabhatiya, and we have another class of literature which are known as Karana texts. What is the difference between Siddhantas and Karanas? Karana means karne ke liye. So it's kind of a practical manual, and it's very simple as far as the mathematical complexity is concerned, mathematical computations are concerned. However, the Siddhantas are very much complex texts, in the sense that the mathematical complexity is very high, the mathematical computations are very tough, and it's very highly sophisticated, and it's very comprehensive. Okay, in the case of Karana text, they are very simplified version of those texts, and they can be used as practical manuals. So now, what are these Siddhantas talked about? Obviously, they'll be talking about different astronomical models, different astronomical parameters, and necessary mathematical tools and ideas which are required for the computation of these astronomical parameters and quantities. Okay, so now let me take 3 different Siddhantic texts from 3 different time periods by 3 different authors. The first Siddhantic text that I'm considering here is Aryabhatiya itself from 5th century from Bihar. The second is Siddhanta Shiromani Bhaskarachu from 12th century Maharashtra. The third is Karana Paddhati, early 16th century from Kerala. Okay, so now when we look at this, I have written this in the Roman script. So it says Yugaravi Bhaganaha Kyugra Shashi Chayagiyushuchilra. Next is Arkaparyayaha Kha Abra Khagana Netra Gunasagara. Nanajnana Pragadbho Tilabalamasa Sukshmam Arkadehe Paryayaha Syuhu. So this is how this read. Now what does it contain? What does it talk about? So I'm sure all of you might be familiar with these terms, at least familiar with these terms. When I talk about Yuga, you might have definitely heard about the term Yuga. Yuga here refers to something known as Mahayuga. When I say Yuga, it's a time period. So it's also referred to as Mahayuga. Maha means Mahad, it's larger period of time. Okay. So now Ravi is the sun. Bhagana here refers to the revolution. Revolution in Hindi, I'll also use some Hindi terms, the parikrama. Okay. So now when I say Yugaravi Bhaganaha, it means the number of revolutions made by the sun. Now the question is made by the sun around what? the number of revolutions made by the sun around the earth. Okay, and that is equal to Kyugr. Shashi means Chaya Giying Yushachura, means the Shashi is nothing but the moon. The number of revolutions made by the moon in a Mahayuga around the earth is Chaya Giying Yushachura. Okay, similarly, Arka is another term for sun, Paryaya is another term for revolution. Okay, so Arka Paryayaha, when I say the number of revolutions made by the sun in a Mahayuga around the earth is Kha Abra Khagagana Netra Guna Sagara. Okay, so similarly, Nana Jnana Pragalpa Tilabala Masa Suksham, etc. are the number of revolutions made by the sun, the moon, and other planets. When I say other planets, Mars, Mercury, Venus, Jupiter, and Saturn. Okay, so now when we look at these three different verses, okay, this is part of a verse. Okay, it's not a complete verse. I have taken a part of the verse from three different texts. All these three texts through these verses talk about one particular astronomical parameter that is known as revolution. Again, more precisely, the number of revolutions. When I say number of revolutions, it is the parikrama. Okay, कितनी बार सूर्य पृथ्वी का भ्रमण करता है एक महायुग में, कितनी बार चंद्र पृथ्वी का भ्रमण करता है एक महायुग में, and so on. So all these texts talk about the number of revolutions made by the sun, the moon, and other planets in a Mahayuga around the earth. Okay, so now first text gives that number as Kyugra for the number of revolution of the sun. For number of revolution of the moon, the same text gives as Chaya Giyingushu Childra. Second text gives as Kha Abra Khagagana Netra Guna Sagara. The same number is given by this second text as Kha Abra Khagagana Netra Guna Sagara. Third text gives the number of revolutions made by the sun as Nana Jnana Pragalpo Tilabala Sukshmam Arka Dehe Paryayaha Syuhu. Okay, so number of revolutions made by the sun, made by the moon, made by the planets in a Mahayuga. Okay, so now they are all talking about the number of revolutions made by all planets in a Mahayuga. So that's very much important. That's why I'm just going slowly. And the first text, let's now concentrate on the number of revolutions of the sun in a Mahayuga around the earth is Kyugra. The number of revolutions of the sun in a Mahayuga given by Bhaskara is Kha Abra Khagagana Netra Guna Sagara. The number of revolutions made by the sun in a Mahayuga around the earth given in Karana Paddhati is Nana Jnana Pragadbha. So now if you analyze thoroughly, you can see that three different texts give the same parameter in three different ways, or in three different phrases. Okay, so which means these three different texts use three different systems of numeration to represent numbers. Okay, which also tells us that there are three systems of numerations that got developed in Indian astronomical context to define numbers, or to express numbers. Okay, to express numbers. So now I would be talking about those three different systems of numerations. Once again, I repeat, three systems of numerations. The first system that I'm going to talk about is Bhuta Sankhya system. Okay, what is Bhuta Sankhya system? So when I say Bhuta Sankhya, Sankhya here refers to the number, Bhuta refers to the physical being. So don't go by the term Bhoot in Hindi. In Hindi, Bhoot is Bhoot Pret Pishach, the ghost. It's not ghost. In Sanskrit or even in Hindi and other languages, Bhuta refers to physical being. So you can think of what is physics called in our own Indian languages or the mother tongue, that is Bhautika Shastra. In Hindi or in any other Indian languages, it is known as Bhautika Shastra. Bhautika refers to physical being. Okay, so Bhuta is physical being. Okay, now Sankhya is number. So now when I say Bhuta Sankhya is the number associated with the physical being. When I say Bhuta Sankhya system, it's nothing but the number associated, the system which involves this particular concept. There is number associated with the physical being. Okay, what do I mean by that? So when I say eyes means EYES, eyes, netra or Ankhe. Okay, when I say Ankhe, it's unique. So everyone has two eyes. Okay, so now the number associated with eyes is number 2. Okay, so this is how the numbers are mapped with the physical beings. And when I say the Earth, there is number 1. Okay, so now just to conclude whatever I have told till now, the word Bhuta Sankhya is a compound word which has two constituents, namely Bhuta and Sankhya, referring to a being and a number respectively. Okay, Bhuta Sankhya is number associated with the being. So now these are the commonly employed Sanskrit terms. Okay, that is physical entities such as Earth. Okay, this will be, of course, in astronomical literature, astronomical texts, you will find these terms in Sanskrit. The Earth is number 1, that is Bhu. Moon is number 1 again. The planets number 9. Then ocean, that is 4. Mountain, it is 7. Fire, that is 3. Okay, now why fire is 3? So the physical entities like this, okay, Earth, Moon, and the parts of human body such as eyes, that is 2 ears, 2 knees, 2 hands, 2 nails or nakha, that is 20. Okay, why fire is 3? So now we have to understand this. Okay, understand the contemporary literature. See, we are talking about the text, astronomical literature or astronomical text from 5th century AD. So we need to there are numbers which are mapped for some entities in contemporary literature. When I say contemporary literature here is where Vedas are contemporary literature during that point of time, Puranas and other sociological factors and the dynasty, these are all coming to picture. Okay, when I say fire in the context of Ayurveda or in the context of in general Indian traditional context, fire is, there are 3 types of fires. Okay, Agni is the term for fire is Agni. So Agni is 3. So the number of, corresponding to fire or Agni is 3. Sky is 0. Why sky is 0? Sky is 0 because sky is, I can say, ether is all pervasive. So when I say all pervasive, it is sarvavyapi in Hindi, we can say. So that's it's infinite, right? So but infinite is not a finite number. So the close finite number close to infinity is 0. So they have used the terms sky, that is akasha, abhra, etc., to represent the number 0. Directions, disha, dik, that is 10. Okay, similarly in contemporary literature, serpent means there are 8. There are 8 ashtanagas which are mentioned in the literature. Horse, that is ashwa, saptashva. Elephant, again diggajas. Okay, in Vikramaditya's court there were 8 scholars, that's called ashtadiggajas. Okay, gaja means the elephant. Okay, so so the number corresponds to elephant is age. Okay, these are very minimum physical entities that I have explained. There are many such entities. Okay, so now, so we have till now we have discussed Bhuta Sankhya corresponds to each particular word. Okay, so now if I have a string of words, suppose if I want to represent a huge number, okay, and I have a string to represent that huge number, say Netra, Kha, Bhumi, Shashi, Sarpa. So what I have to do, I have to assign numbers to each. Now when I say, when I talk, you can think of you know, the number associated with each of these individual objects or the physical entities. So Netra here refers to 2 because Ankhe, Netra means Ankhe. Kha means Akasha or this ether or sky. That's again 0. Bhumi is earth, that is 1. Shashi is again moon, 1. Sarpa is 8. So the individually these numbers are 2, 0, 1, 1, 8. But when we read it as Netra Kha Bhumi as a single sentence or a single phrase, Netra Kha Bhumi Shashi Sarpa, we have to reverse the order, and the number when we reverse the order, the number corresponds to that is 81102. This means if I have a string Netra Kha Bhumi Shashi Sarpa, which means 81,102. Okay, so that's the number corresponds to Netra Kha Bhumi Shashi Sarpa. And Now, I'm posing a question here. What is the number corresponds to rasa? So you may have, there are in this, that when we talk about the term rasa, we can think of two rasas. One is the navarasa, which appears in the literary context or in the context of Natya Shastra, that is Nayan. You can see on the right hand side. And another rasa, which is, we all experience, the nine rasas, which comes in Natya Shastra, which we may not be able to identify or experience, or we may not be able to enact, but definitely the other type of rasa that you can see on the platter, that is Shad rasa, the six tastes, bitterness, saltness, sweetness, etc., that we experience in day-to-day life. Okay, so even though there is an ambiguity for this particular term, the Indian Indian astronomers, okay, they have taken rasa for number 6. So consistently throughout any text, okay, and hence in that context there is no ambiguity, okay, because that is more common man's rasa, okay, because everyone experienced this rasa, but this other is more specific academic discipline, okay, with respect to some specific academic discipline. So now I hope you remember this particular slide, which we have this is the slide we have started our discussion, okay. So we have considered three texts, and in these three texts, the second text, that is Bhaskara Siddhanta Shiromani, uses Bhuta Sankhya system to represent numbers. Okay. Now Arka Paryayaha means the number of revolutions made by the sun in a Mahayuga in around the earth. And for okay, one more thing I would like to tell you. I told that Mahayuga is nothing but it's a larger period of time. And what is that period? It is 43 lakhs 20,000 years. Okay. Once again, I repeat, 43 lakhs 20,000 years is the time period of a Mahayuga. So now the question here is, what is the number of revolution made by the sun, revolutions made by the sun around the earth in a Mahayuga? And the answer for that is Kha Abra Kha Gagana Netra Guna Sagara. Now, how do we decipher this? We need to know Bhuta Sankhya system. Now, at this point, we know the Bhuta Sankhya system. Let's try to decode this. Kha here is 0 because it is Akasha. Abra is another synonym for Akasha. Kha is again 0. Gagana, Gagan, it's also Akasha, that is number 0. Netra is 2. Guna is 3. Guna means qualities, that is number 3. Then Sagara, that is ocean, that is number 4. Okay, so now when we read this Kha Abra Kha Gagana Netra Guna Sagara, so now what we have to do is we have to reverse the order. Okay, so now when we reverse the order, what we get is 4, 3, 2, 0, 0, 0, 0. So now the sun revolves around the earth in a Mahayuga 43 lakh 20,000 times. Okay, so that's the answer we get. Okay, so again, the text talk about different revolutions of moon and Mars, Mercury, etc. Will not bother about those revolutions. Now we are at this point, we are trying to see these three different systems of numerations. Okay, in order to understand mathematics or the astronomy, so in order to understand astronomy, we need to know mathematics. In order to know mathematics, we definitely need to know number system. Okay, because that's the basis of basis for mathematics. So without knowing number system, we cannot understand any mathematical concepts or theories or tools. Okay, so this is how the Bhuta Sankhya system works. Okay, so now let's go to the other system of numeration. The other system of numeration is Aryabhatan system of numeration. In Bhuta Sankhya system, we have discussed that the numbers are mapped with objects. But in the case of Aryabhatan system, what happens is it's a new system. It is invented by again Aryabhata, and he uses this system in his treatise or in his text called Aryabhatiya. So what he does, he uses letters in Sanskrit alphabet. Letters in Sanskrit alphabet is almost similar to letters in alphabet of other language, Indian languages as well. Okay, now we can divide alphabet letters into two categories. One is vowels and consonants that you already know. I'll just pronounce it. Okay, let's go back to first standard. Ka kha ga gha nga cha cha ja ja nya ta tha da da na ta tha da da na pa pha ba ba ma. These are the consonants. Then e e u u r r a I o au. These are the vowels. Now what does Aryabhatta do? Aryabhatta assigns numbers 1 to 25 for ka to ma. Ka kha ga gha nga cha cha ja nya 1 2 3 4 up to ma, it is 25. Yaralava Shashasaha, he assigns number from 30, 40, 50, 60, 70, 80, 90, and 100. And for vowels, he assigns numbers 10 raised to 0, 10 square, 10 raised to 4, 10 raised to 6, 10 raised to 8, up to au, he assigns number correspond 10 raised to 16. That is, number corresponds to au is 10 raised to 16 and a is 10 raised to 0. Okay. Now, how does this system work? Let's take the same example which is given in the first slide. Okay, we have seen, if you remember, that's why I have repeated that slide several times. I just repeat it once again. Yugarave bhaganaha kyugra. The number of revolutions made by the sun around the earth in a Mahayuga is kyugra. And that term, phrase kyugra, gives the number which could be understood from Aryabhattan system of numeration. So now we have this phrase kyugra. What do we need to do first? We have to split this into two subunits. So when we split this into two subunits, we have, in this particular phrase, we have two subunits, Q and Gr. Now, again, in the first subunit, we have three different letters, that is Kha, Ya, and U. Okay, and if you go back to this particular table, Kha corresponds to number 2, Ya corresponds to number 30, and U is 10 raised to 4. Now, what you have to do is you have to add these two numbers. The numbers corresponds to these consonants and multiply that with the number corresponds to the vowel. So 30 plus 2 you have to do and multiplied by 10 raised to 4. Which will you what will you get is 320000. Now let's take the second subunit, that is Gr. Again, in this next second subunit, we have only two letters, that is G and R. Number corresponds to G is 4 and number corresponds to R is 10 raised to 6. Now, as we have done in the case of previous subunit, what one has to do is the number associated with the vowel has to be multiplied by the number associated with the vowel. Now, number associated with the vowel has to be multiplied by the number associated with the consonant, or vice versa. So when we do so, for the second subunit, what we get is 4 into 10 raised to 6. Okay, so now we have two numbers correspond to two subunits, and if we join them together, when we join these subunits, we get the phrase kyugra. While joining, we have to add the corresponding numbers. Okay, when we add the corresponding numbers, this is how the mathematical equation would look like: kha plus ya into u plus gha into r. And if we apply the numbers corresponds to it, 2 plus 30 into 10 raised to 4 plus 4 into 10 raised to 6. That will give us 43,20,000. So according to Aryabhattan system also, the number kyugra corresponds to the same number 43,20,000, which is the number of revolutions made by the sun in a Mahayuga around the earth. Okay, so we have now discussed this second system of numeration. Now let's go to the third system, which is Katapayadi system. So Katapayadi system is sort of similar to Aryabhattan system, where it uses letters in Sanskrit alphabet. But here, when I say letters, Katapayadi system do not use vowels. When I say Katapayadi, you see the name itself, Katapaya Adi. Adi refers to etc. Okay, you might have heard the term ityadi in Hindi. If you just remove that iti, then what remains is adi. Adi has several meanings, that is beginning and so on. But adi also has a meaning etc. So when I say katapayadi etc., katapayadi etc., ka etc., ta etc., pa etc., ya etc. So now if you see the table, you can see ka, etc. When I say ka, kha, ga, ga, nga, cha, cha, ja, ja, nya, it all ends up to nya. Then you have ta, etc. Ta, tha, da, da, na, ta, ta, tha, da, da, na. Then we have pa, etc. That is pa, pha, ba, ba, ma. Then we have ya, etc. That is ya, ra, la, va, sha, sha, sa, ha. Okay. So now what the author of the inventor of Kattapayadi system did is he has assigned numbers 1, 2, 3, 4, 5, 6, 8, 6, 7, 8, 9, 0 for ka, etc., ta, etc., pa, etc., ya, etc. Which means when I say ka, it is number 1, kha, it is 2, ga, it is 3, and so on. Okay, here it is to be noted that only consonants have numerical significance, which means the numbers are only assigned for consonants, not for vowels. When I say like that, what is the speciality? When I say ka, it is also number 1. Ka, it's also number 1. Ki, ki, ku, ku, ke. That's all these subunits are represent number 1. Similarly, when I say ga, ga, gi, gi, gu, gu, it's number 3. When I say nana, nana, nani, nana or nani, so it's going to be 0. Okay, whether it's na or it's ni or nu or ne or nai, it is 0 because the vowels do not contribute to the numerical system. Okay, again, this is with respect to each individual letters I am talking about. So when we say the entire phrase that we have, again, you have encountered this particular phrase nana jnana pragadbha in the previous slide, the first slide. Okay, the same phrase I am using it here. So now what we have to do is we have to assign the numbers. Okay, and before assigning the numbers, what we have to do is we have to again split this into several subunits. Here we have 1, 2, 3, 4, 5, 6, 7 subunits. So you have na, nya, na, pra, ga, bha. So these are the different 7 subunits that we can think of, and the number associated with na is number 0 because it's the number associated the consonant na. Jna is 0 because here there are 2 consonants, but we have to take only that consonant which is proximate to the vowel. Na is 0. Pra is again the number associated with pra is number associated with ra, that is 2. Ga is 3. The bha is bha, that is 4. Okay, so now we have numbers associated with each subunits, and in order to get the number associated with the entire phrase, what we have to do is we have to reverse the order, and when we reverse the order, what we get is 43 lakh 43. When you can see, you can just see the reverse the order with 4320000. So we get 43 lakhs 20,000. So again, according to the text Karana Paddhati, which we have seen as the third text in the first slide, we have 43 lakh. Nana Jnana Pragadbha is the phrase which is used to represent the number of revolutions made by the sun in a Mahayuga around the earth. Okay, and there also it comes to be 43 lakh 20,000. So what is the takeaway from this? Okay, there are three different texts use 3 different systems of numeration, which means we can use several, there are 3 different systems of numeration that got evolved in Indian astronomical context to represent numbers. Okay, means with different systems of unit, a system of system of numeration, we can represent the same number. And even among the single system of numeration, we can use n number of phrases to represent the same number, because here you have Nana Jnana Pragadbha we have used, that is 43 lakh 20,000. Okay, we can use some other phrase itself to use to represent this number, because to represent number 1 itself we have 4 letters. Okay, not just 4 letters, it's combinations like kaka, kiki, kuku, titi, tutu, etc., papa, pipi, pupu, ya, ya, yi, you. So we have many kind of combinations that we can think of, and here we can ask several intellectual questions. Why are these 3 different systems of numerations? Which are efficient ones? Okay, so in this online talk, we need at least 2 to 3 hours to discuss only for these 3 systems of numerations, and to go deeper into it, to ask several intellectual questions. Also, which is the we can also ask which is the efficient system among this. So I request all the participants, you can think of, if you understood all these 3 systems of numerations, you can actually think, and you can do some exercise and think of and come up with an answer to decide which among these 3 systems of numeration which is the most efficient one. You will get one of the system is more efficient. Then you can also answer why are the other systems are not that efficient as the third system, or whatever the system that you have found. Even if the system that you found, any one of the system is more efficient, are there any drawbacks in that particular system? These are the different intellectual questions that we can address at this point. Okay, so this is, by this slide, actually I conclude the 3 different systems of numerations, and how Indian astronomers used these 3 different systems of numerations to represent numbers. Okay, so now I'll just try to I'll use some time to just quickly go through some of the verses which represent some of the mathematical quantity. So numbers, it's fine. Now if we have any particular mathematical tool or mathematical idea or mathematical quantity, how did Indian astronomers express this? Okay, so for that I'm just considering a mathematical quantity which is known as pi. Okay, this you can see here, evolution of pi, that this pi is a Greek symbol. When we write this Greek symbol pi, it's a mathematical quantity. I'm sure all of you might have come across this particular mathematical symbol or mathematical quantity. So you may answer it as 3.14. If I ask you what is the value of pi, which is you may answer it as 3.14, but it's very crude approximation of pi. Why it is crude approximation? Because it's an irrational quantity. Okay, irrational number. So it's just an approximation. So you can get an accurate value, precise value of pi only if you go up to the infinity. That is 3.14156. You have to go like this up to infinity, then you will get the precise value of pi. So now, why Indian astronomers were interested in this? Because the planets. For that, we need to know how pi is defined. So for that, we need to bring the concept of circle. Okay, I'm sure vritta, or the circle, you are aware of the geometrical figure circle. So when we say the circle, it has a diameter and it has a circumference. Okay, so now if you take a circle, its diameter, the ratio of its circumference to its diameter will remain a constant. So if you take an infinitesimally small circle or an infinitesimally large circle, the ratio of the circumference to its diameter for both the circle would be equal, and that will be a constant, and that constant is known as pi. Okay, so whatever be the size of circle, that this particular ratio is going to be a constant for all circles, and that is pi. So now why Indian astronomers were interested? Because the planets are moving in a circular orbit, and interplanetary distance is a radius, which is the half of the diameter. So we need to have the knowledge of, we should have the knowledge of pi, or the relation between circumference and the diameter, to understand the celestial phenomena. So the first approximation given by Aryabhatta by this particular verse, I'll just define, because of the paucity of time, I'll just define Chaturadikam Shadamashta. I will not explain, I'll just define Chaturadikam Shadamashtagunam Dvashashtishtata Sahasranam Ayutadvaya Vishkambasya Asanno Vrittaparinaha. So he gives the diameter of a circle as 20,000. If the diameter of a circle is 20,000, then its circumference would be 62,832, and that 62,832 is expressed by Chaturadikam Shatamashtagam Dvashashtishtata Sahasranam. Ayutadvaya Vishkamba is the diameter, Ayutadvaya is 20,000. So now if we find the value ratio of circumference to the diameter, we have 3.1416, which is an approximation of pi. So now let's go back to just to see the evolution of this particular quantity, Bhaskara Siddhanta Shiromani Vyase Bhanandagnihate Vibhakte Khabana Suryehi Paridhihi Sukshmaha. He gives the same value as I'm just moving fast because I don't have much time. So 3927 by 1250, that also gives the same approximation. Another approximation is actually is vyavahara for practical purposes. One can use another ratio, that is dvavimshati. Dvavimshati means bayis, vimshati means bees. Okay, dvavimshati means bayis. Shaila is, again, it's a Bhuta Sankhya system. Shaila is Parvata or the mountain, that is 7. 22 by 7 is a crude approximation of pi again, and that can be used for all practical applications. Then in 14th century, Madhava from Kerala school gives more precise, more and more accurate value, or more and more approximation for the value of pi using this particular Vibhudanetra Gajahi Hutashana Triguna Veda Bhavarana Bahavaha Nava Nikharvamite Prativastare Paridhimanamidam Jagadurbudhaha. So the first line gives the circumference. When here he uses the Bhuta Sankhya system. If you use the Bhuta Sankhya, now you are already familiar with the Bhuta Sankhya system. If you use the Bhuta Sankhya system, what we get is 282743388233, and Navadnikharva, which is the diameter, that is 9 into 10 raised to 11. You get the value of pi as 3.1415926535992, which is correct up to 11 decimal places. Then how did Madhava get this? Madhava obtained this by this is the first verse that we have seen. Vyaseva ridhinihate rupahrute vyasa sagarabhihate trisharadi vishama sankhya bhaktam swam pranam pathakramat kurya. So by this verse, when we if I have, so in classroom teaching I use explain this verses word by word, and but again I'm sorry for not explaining whatever, but the final result, that is nothing but it is nothing but the I have not put that here. So it's actually, if the circumference is C and diameter is D, then C can be expressed as C equals 4 into D multiplied by 1 minus 1 by 3 plus 1 by 5 minus 1 by 7, etc., up to infinity. It goes up to infinity. So this particular verse gives an infinite series expression or an infinite series expansion for the computation of pi, or for the computation of circumference if you know the diameter. Okay, so now I wanted to discuss this particular point. Wanted to just define this series because historically this becomes an important aspect, because Madhava from 14th century is the first person who introduced the concept of an infinite series. He is the first mathematician. I mean I'm not talking from Indian perspective, but globally Madhava is the first person who has introduced the concept of infinite series. He gives the first time he gives the infinite series. Later, 2 centuries later, Newton and another mathematician called Leibniz. Newton, obviously we all know about Newton. They give the same series, and they have discovered independently, and they also give the same series. And one more person called Gregory, and that series in modern mathematical context is known as Madhava Gregory Leibniz series. But previously it was known as Gregory Leibniz series or Newton's series or whatever. But we clearly know that the Madhava has discovered 2 centuries before Newton or Gregory or Leibniz independently. So now even the modern mathematicians accept this contribution, and it is also known in modern mathematical context as well. It is known as Madhava series or Madhava Gregory series or Madhava Leibniz series and so on. Okay, so I think this is sort of a logical conclusion that I can make at this point. Thank you so much. Yeah, thank you so much.
Thank you so very much, Dr. Pai, for such an astonishing and mesmerizing presentation of yours, taking us into this voyage of, exploring the Indian knowledge, the Indian traditional knowledge, and also helping us, to get the vast wisdom of the past to get translated. You have become, a conduit. You really has helped the current to get connected with the past. And it was truly an exceptionally brilliant presentation of yours. And we feel like, diving more deep into the very essence of this Indian knowledge systems. I think, because of paucity, you have not been, and as you have been rightly indicating, we have also felt the urge that there is a greater need to have more in-depth dialogue into this, more deliberations to happen. But you have really has helped us to unearth many of these, how scientifically, it was being done, and especially the use of the Sanskrit text. Not many of us, I believe, if we really conduct a survey, each one of us strongly would feel that you have given us a very new perspective altogether when we think about, digging out, the knowledge of the past, especially in mathematics and astronomy, how with the Sanskrit text this was being done. This has become something that everyone, and the way that you presented this in a very lucid manner, in a very plain, simple ways, that has made a very deeper impact. And each one of us really have felt truly inspired enough to have many more interactions with you and to see to it that we are able to capture this also. There's a greater need, to have the experts, the great experts like you around who are able to translate that wisdom, that knowledge which was being captured, and to let our current generations to know about it. And we fully laud the efforts which are being made, as a special mission of IKS with the government, by many other organizations who are really partnering with it. And this is to tell to our younger generations, the great giants, on whose shoulders, we are running. And truly remarkable presentation of yours. We cannot really thank you enough. And we know that because of paucity of time, but this has really made us to ponder that we may have to do more in-person programs, and in order to see to it that we have better, exchange of more ideas and more knowledge sharing. But you have really made us to take a dive deep into, the field and to know more about it. Even this Aryabhatiya, we have been knowing, anyone asked for the Aryabhat's contribution, but in such a wonderful manner that you have mentioned. This has just been, it's like an image which has been created, and everyone of us now is able to know that what was contribution all about, and also the various different school of thoughts which have been there, and simply remarkable, Dr. Pai. We remain ever grateful to you, and we really look forward to having many more interactions with you, and I'm very much confident that our attendees over here have got immensely benefited, with the level of expertise that you have shared with us this afternoon. With your permission, maybe can we make our floor open for questions? Yes. We have more than 500 of our colleagues who are being here. So this is now to request all our attendees, after listening to Dr. Pai, each one of us definitely, we are feeling more inspired to come forward, and then asking many of them. We are more inquisitive now to know more. As we always say, it's good to know that what we don't know, and we are able to now know about it, that how ignorant we have been about our past. We are running in the present, we are looking at the future, but how rich, India as a country, and our propounders, who have really gifted to the world, not only to the India, but to the global community, to the knowledge domain. And it's really so good to discover and rediscover our past for future, and also to treasure it, to cherish it. So I would like to now make the floor open for questions, and with the ability of our such an esteemed expert and a colleague, Dr. Pai, we would really like to make the best use of his ability over here with us. We would like to make the floor open for questions, requesting each one of our colleagues who are being connected with us online, please raise your digital hand. A very humble request. Please ensure that if you're genuinely wanting to ask a question, raise your digital hand so that we can make the best use of the ability of our time. Or those of you who would like to ask a question in the chat mode, you're most welcome. You can drop us a question, and we'll be more than happy to connect you with our esteemed speaker. This is for Mr. Alok Chaube. Mr. Alok, your audio device is not connected. I can't really can pass on the audio connect to you. I just request you, if you would like to get connected. The same is for also for Veena Rani. Veena, please ensure that you have a correct audio connection. I'm passing on now, going to Mr. Deepak Kumar. Mr. Deepak Kumar, you have raised your hand. I do hope that you are wanting to ask a question. Mr. Deepak Kumar, could you please unmute yourself and ask a question to our esteemed speaker? This is for you, Mr. Deepak Kumar. Could you please unmute yourself? If not, Deepak, I have muted you now from here. I'm quickly moving on, and this is for Dr. B. Baran Kumar. Dr. B. Baran Kumar, you have raised your digital hand. Could you please unmute yourself? Dr. B. Baran Kumar, could you please unmute yourself? Dr. Pai, I just request you kindly bear with us. This is what happens in the online.
So, fine.
Dr. Baran Kumar, could you please unmute yourself? A request to you, please raise your digital hand if you are wanting to ask a question. This is for Dr. Ramya A. Ramya, there is no audio device with your connection. And the same is also for Dr. Sadhu Ranganathan. Please kindly ensure that your audio device is fully being connected. Hemraj Kumawat, Mr. Hemraj Kumawat, could you please unmute yourself? Mr. Hemraj Kumawat, could you please unmute yourself? It seems that you have raised the hand, but not perhaps have been just trying. This is for Kanaka Sabai. Kanaka Sabai, could you please unmute yourself? This is for you. I'm extremely sorry. We are taking not much of your time, Dr. Pai.
No, okay. Is it a common problem? It may be a common problem for they may not be.
Like, no. So sometimes they just want to explore. I just want someone, this is for MS Shrifail Jiburi. Mr. MS Shrifail Jiburi, I have unmuted you. Mr. Jiburi, I have unmuted you. Would you like to ask a question? Or sometimes what happens, I just want to see, especially those who gets connected for the first time in the device, and then they just want to see how that particular option would work. And that's how they get a wrong trigger. So this is what the online and the in-person. In-person, we can make out whether someone is interested in asking or not. But here it raises the wrong alarm. Yeah. This is from Mr. Pankaj Arya. Mr. Pankaj Arya, could you please unmute yourself? Mr. Pankaj Arya. I'm extremely sorry for watching in your time now, Dr. Pai, because this is for Parul. This is for Parul Sonadare. Parul Sonadare, could you please unmute yourself? This does again. I believe we need to be very, very careful, and this is what we have always been requesting. If you are wanting to ask a question, then only please raise your hand. Mr. R.S. Soni. Mr. R.S. Soni, I have unmuted you. Yes, we are connected, Mr. Soni.
Thank you, madam. Actually, my question belongs to is there any authentic source available to read on our own laser? Because I want to research more on the use of this original text into artificial intelligence. So, do you see any connection between this AI and the original text of the Aryabhatta and Bhaskaracharya?
Could you please introduce yourself, Mr. Soni? Can we request you? And thank you for breaking the silence also. I must really appreciate and thank you especially for that. Could you please introduce yourself, Mr. Soni? It would really be nice if you can introduce yourself.
Okay, good afternoon. I am R.S. Soni from National Academy of Defense Production, Nagpur.
That's nice. That's good to know. Thank you so very much, Mr. Soni, and I request Dr. Pai to kindly give his expertise.
Dr. Soni, frankly speaking, no, I don't know. I have zero expertise in artificial intelligence, how it works, and it's how it could be, how Indian Aryabhatta's algorithm or whatever could be used for AI. So it's a completely multidisciplinary, interdisciplinary, where two different experts, one AI expert and the expert like me, should sit together and come up with the ideas. So
Sir, but is there any authentic source where we can, as a general
Of course.
population, we can
Yeah,
read
yeah.
the source
Obviously,
text?
I would be happy to help you. Providing authentic sources.
Okay, sir.
You are free to write to me. You can go to the website and get my email ID and free to write to me for
Okay. Okay.
be in
Thank you very
touch.
much,
And
sir. Thank you very much. Thank you,
And Dr.
ma'am.
Sonia, you're an esteemed member of DELNET. We would be more than happy to get you connected with Dr. Pai. So you can just always can write to us, and we'll be really delighted, to get you connected. And thank you very much. And this also really, gives us yet another viewpoint that we need to explore. And this is how this, the AI and then bringing this Indian knowledge systems and also its applicability, in the specific domains of knowledge, how we can do that. And I believe this has also garnered interest now, and many of our AI experts would also be there in this forum today. And I believe we can in some of the forthcoming programs, because we're also doing a good number of programs now on AI, and we would really be happy enough to also deliberate on this, how we can integrate and can think about utilizing the best of both the worlds, our traditional knowledge and how using the most emergent technology, and how we can reach up and do something good for the society as such. Thank you very much, Dr. Soni. Your question has truly been appreciated a lot. Thank you very much. Thank you indeed. We'll just quickly move, and we would just move in quickly now to see. We have Rohini Nembedkar. Rohini ji, I'm just unmuting you and requesting you to unmute yourself. Just allow me a minute. I believe you have logged out of the system. Yes, you are logged out of the system. This is for Rohini Nembedkar. No, you have logged out the system. This is for Sekhar Doraiswamy. Mr. Sekhar Doraiswamy, could you please unmute yourself? This is for Mr. Sekhar Doraiswamy. Could you please unmute yourself? Mr. Sekhar Doraiswamy, could you please unmute yourself? This is to request you, please unmute yourself. You have raised your digital hand. If you are wanting to ask a question, please unmute yourself. This is for Mr. Sekhar Doraiswamy. If not, let me just mute you from here and quickly move on. Shikha Dubey. Shikha, could you please unmute yourself to ask your question? Shikha Dubey. Shikha, could you please unmute yourself? If not, this is for Shiva Kumar Khandare. Audio device is not properly connected. I can't give you and try to connect. Shradhanand Das. This is for Shradhanand Das. Could you please unmute yourself? Shradhanand Das. Mr. Shradhanand Das, could you please unmute yourself? Sorry for taking your time, Dr. Pai.
It's okay. No worries. Yeah. So yeah.
I'm just now, so we are through with this, but I would just quickly like to go once again to see if anyone left out there. And let me just ask, let me just see if we have. This is Vipul Kakkar. Yes, we have muted everyone. You have said, madam, you have muted everyone. Yes, we have muted it by default. And if you want to ask a question, raise your digital hand. And I will just try. You have said that you want to ask a question. Allow me a minute. And I'm giving you. I have unmuted you. Please unmute yourself. This is from Mr. Vipul Kakkar.
Yes, yes.
Yes, Mr.
Yes,
Vipul, you are connected. Yes.
yeah.
Introduce yourself
I'm
and ask the question.
yeah. Okay.
Yeah, you
So
got it.
I'm Dr. Vipul Kakkad from Central University of Rajasthan. So it was a very nice lecture, but I would like to ask the numbers, the pattern you were saying in your lecture. So basically, it is Anka Naam Vamato Gati,
Exactly. Exactly.
right?
Yeah. But it's
Exactly.
actually. Yeah. Please continue.
Okay, so I would like to ask, what is the oldest history that you find in Indian literature for
Mm.
Ankanam Vamto Gati, or later it changed to the usual system,
Mm.
because it's very natural. Ankanam Vamto Gati is very natural. So what we do is Ikai Dahai Sekada Hajar. So Ikai should place at the right
Correct.
place. So
Exactly.
it's
Exactly.
very
Yeah.
natural and scientific. So,
Mm.
what is the oldest literature that you find the Ankanam Bhamto Gati system of?
Okay. So when I say oldest, so when we say Bhuta Sankhya system, the numbers representing as mapped with objects, physical objects, that we can go back to say 14th century BCE, where there is something known as Chanda Shastra. There is a text called Pingala's Chanda Sutra, where he uses while giving the characteristics of meters. Okay, you might have known about Anushtup Chanda or Anushtup meter or Shartula Vikridita and so on. There he uses this Bhuta Sankhya system. But Bhuta Sankhya is usage of Bhuta Sankhya system to represent an arbitrary number. It is that we can find from Aryabhata's literature. Okay, so that is the oldest text for current, I mean, time being, we can actually trace back. Okay, that's Aryabhatiya. Now, another question that you have asked, that's Ankanam Vamato Gatihi. See, in Indian context, representing number, say, if I want to represent number, say, 23, okay, I have to represent it as 3 and 2. 3 and 2 in the sense, it's not the symbol 3. It's the 3 means, suppose the Bhuta Sankhya, in Bhuta Sankhya, suppose it is Guna and 2 is Netra. Guna Netra, when I say Guna Netra, where Guna comes first, okay, that represents the unit place. When I say an arbitrary number, it's in decimal place value system. Okay, in the rightmost, from modern context, the rightmost number represents the unit, the place represents the unit place, then 10th, 100th, and so on. But in Indian system, it is reverse. Because as you have correctly pointed out, it's kind of very natural and scientific when an oral tradition is concerned. Because the tradition in India was mostly oral. When I say Gunanetra, if I want to say Vibhudanetra, Gajahi, Hutashana, Triguna Veda Bhavarana Bhavaha, so Vibhuda, that comes at it's scientifically or more natural to consider it as the unit place than the last one. Otherwise, you will by going to the end, you may forget the first while hearing, you may forget the first word. Okay, so in India, irrespective of the time period, the number system was always from left to right. Left to right, when I say left to right, the left one was the unit place, then next to that is 10th place, and so on. So now, again, your other question is, we are using now the other system. So that's in the modern mathematics. So that's when we started adopting European mathematics, we have started representing numbers as symbols. We are using the European model, which is from right to left. That is the rightmost digit represents the unit place, and so on. This also has a history in the sense, now if you go to Persia and Middle East, there is a number system called Abjad. Okay, so that Abjad in Bhuta Sankhya and Katapayadi, we are actually reading from right to left, right? So unit place would be at the leftmost, and if we want to convert this in the modern terms, we have to reverse it and read it. Okay, but the Abjad is actually reverse of this system. Similarly, if you think that if you see this all Indian languages, we are writing from left to right, right? But if you see the Persian or Arabic or any other, even Urdu for that matter, is written from right to left. Okay. At the same time, their number system, say the abjad that I was talking about, it is written from left to right. Okay, so now when the knowledge transmission had happened, this the numerals that we call today in modern mathematics, they are known as Hindu-Arabic numerals. Sometimes Arabic numerals, then now it is in the Hindu-Arabic numerals because it is originated in India and then it went to Persia and Middle East, and then it went to Europe and it came back to India during colonial period, right? Or the when the modern mathematics got developed. So now when it whatever the system that we were using, when it went to the Middle East, there the entire the writing system and the representing number system was completely ulta as compared to the Indic version. So when we say this system, this is the uniqueness of Indian system of representation. Now we are more familiar with modern system. That is how I have to say you have to reverse the order. Okay, I have used the word reverse the order. In the Bhuta Sankhya and Katapayadi, I have told that you have to reverse the order. Suppose if we are living in, say, 5th century, I don't have to say that, because we don't know the current system. Now we are more familiar with the current system of numeration. In order to understand our system based on our current understanding of current modern system, I have to intentionally say that you have to reverse the order. That Sanskrit version of that is Vamat Ankanam Vamato Gati, and that Ankanam Vamato Gati also you find in 18th century literature, not before that. Before that, it was very natural. For example, Bais, when you say Bais, Ba is 2, or Ikis, let's say Ikis. Ik is 1, and its Vis is 2. Ikvis becomes 1 and 2. That's actually not 12, it is 21. So the unit place is told at the beginning, and then, yeah.
Thank you very much, Dr. Pai, for a very exhaustive reply. And thank you very much, Dr. Thakkar, for asking and really making it possible for us to further have a good knowledge sharing sessions. Thank you very much indeed. Now we would like to, I'm just trying to get connected with Rohini Nimetkar. Rohini ji, requesting you, I'm just giving you a connect. I'm glad that you could get reconnected into the system. I sent you a muting request. Please unmute yourself and ask the question. This is for Ms. Rohini Nimetkar. Rohini Nimetkar. Rohini, this is to request you. I believe
yes, yes, ma'am. Yes. Am I audible, ma'am?
Very much.
Hello?
Glad we could get. Yes, we are audible. Please
Yeah.
introduce yourself
Okay.
and ask the
Ma'am, yes. I'm Professor Rohini Nimbekar from Sipna College of Engineering and Technology, Amravati. Sir, my question is that I'm teaching the Bhuta Sankhya system, the Katapayadi system as well. But while teaching both the systems as well as the Chanda Shastra, what I found that there is an interconnection between the Marathi literature and that the Chanda Shastra. So I want to know more on that one.
Okay, Marathi literature, when you say Chandas, okay,
Yeah.
Chandra Shastra
Yes,
is
sir.
a different, Bhuta Sankhya is a different thing, and
Yeah. Yes, sir. Yeah.
different thing. Chanda
Yes.
Shastra is, is a discipline which is used to understand the metrical composition or the meters in a composition. For example, Shardula Kridita.
Yes. Akshara Gana.
For example, Surya Shver Masajas Tatha Saguravaha Shardula
Huh.
Vikriditam. That is Lakshana, characteristic of the meter, Shardula Vikridata. Now here Surya and Ashwa is the term used. Surya here refers to number 12. Ashwa is 7.
Yeah.
So here 12 syllables and 7 syllables. These are the in the context you have to consider it as 12 syllables and 7 syllables individually or independently. Yeah. So now when you come to the Bhuta Sankhya system, you are representing this particular concept to represent any arbitrary number, not individually separated numbers. Here 12 and 7 are independent numbers. Okay, that's one thing. And the second, when you talk about Marathi literature, when you talk about literature, it will be composed in verses and prose. Okay, if it is composed in verses, it follows some metrical pattern. It has some meters. So when you talk about meters, the Chanda Shastra comes into picture. So that is the relation that is established with the Chanda Shastra and Marathi literature. Not just Marathi literature, any literature in Indian languages which is composed in poems or the verses.
Yes, sir. Thank you so much, sir. Thank you so much.
Thank you, Professor Rohini. Thank you so very much indeed. Thank you. And we'll just have once again a very quick relook if there is anyone else who has been left out and who would like to ask a question. Dr. Pai, just allow me a few minutes.
Sure, you can take, yes, I'm free. I don't have any other class today, so I'm
just quickly glancing through to have a recheck if this is just to inform all our colleagues that we will be uploading the entire video recording of the session with the permission of Dr. Pai. We are going to upload this on the DELNET's YouTube channel because we could see that many of the requests in the chat box to get an access to the recording. So that will be available by tomorrow. by tomorrow noon. We are going to upload it on the DELNET's YouTube channel web view. You can just like Google and see DELNET YouTube channel web view. Let me just see. We have Dr. Sekhar Duraiswamy. I can see that you are wanting to ask the question. You have raised your digital hand again. This is for Mr. Sekhar Duraiswamy. Can you please unmute yourself? And I can see that you have raised both your digital hands. That is, you have logged in from 2 different locations to the system and wanting to ask. Please unmute yourself, Mr. Sekhar Duraiswamy. I believe perhaps you have some technical issue in getting connected. And so this is just to inform you all that you would be having an access to the recording. Mr. Srinivasan N. Mr. Srinivasan N, could you please unmute yourself? Mr. Srinivasan N, quickly, if you want to get connected, unmute yourself. I'm extremely sorry, I'm compelled then to mute you. This is Suraj Motirandikar. Mr. Suraj Motirandikar, could you please unmute yourself? Mr. Suraj, Mr. Suraj.
Yes, madam. Oh.
Yes, you are connected. Good, please introduce yourself and ask the question, Mr. Suraj.
Okay. My name is Suraj Motirandekar. I am librarian Abhinav College of Computer Science and Management, Pune.
Oh,
so
okay.
my question is,
Yeah,
hello
please,
sir,
please.
I am audible.
Yeah,
Okay.
very much audible.
So my question is, why did Indian mathematics prefer expressing with math in words rather than numbers?
Okay. I'll just go back to the slides. Okay. Okay. So now, so one thing we need to understand here is that the knowledge transmission in Indian astronomical texts were mostly oral. Okay. So it's easy for somebody to remember in the form of verses. Okay. For example, if I okay, for best example I would show is, so you can see the slides here, right? So this is known as Chandravakyas. Okay, this is this comes in astronomical text, which are something known as Vakya system of astronomy. So when I say Vakya, this refers to a sentence, but in astronomical, especially the Vakya system of astronomy, this represents a mathematical quantity. Okay, when I say, you can see here in the slides, I hope slides are visible, right? I'm just
Yes.
Visible, yes.
Yeah. Okay. So Chandravakyas, they are 248 in number. So now if you read that, so Girna Shreyaha, Dhenava Shrihi, Rudrastu Namyaha, Rama Giyate, and last you have Bhavet Sukham. These are 248 sentences. Okay. So now what are they? They are known as Chandravakyas, means they are something to do with Chandra means moon. Okay. So they give the longitude of the moon at a specific day. For example, when I say Girna Shreyaha, it gives the longitude means the position of the moon. Astronomical position, I could say, that's the longitude. That is nothing but 0012 degrees 3 minutes. When I say here degree, you know that it's a mathematical unit. Minutes is also here. It's 1/60th of a degree is minute. Okay, 12 degree 3 minutes is the position of the moon on first day. With respect to some astronomical phenomena, okay, we'll not bother about that astronomical phenomena now at this point. Okay, now the position of the moon on second day is 24 degrees 9 minutes. Third day is 6 degrees 1 rashi means 30 degrees 6 degrees, so 36 degrees 22 minutes. And when you go up to 248th day, the position would be 27 degree 44 minutes. So now, so people used to by heart this all 248 vakyas. Say, so it's easy for you to by heart Girna Shreyaha, Dhenava Shrihi, Rudrastu Namyaha. You can by heart these vakyas in order, right? As compared to 00123, 0024, 09, you cannot reproduce numbers in sequence. If you by heart them, you may get confused. I'm sure you just try for five numbers, okay, five digit numbers, and try to by heart them, and tomorrow you just try to reproduce them. It's not going to happen. Even our bank account, if somebody asks us what is your bank account, you may not be in a position to tell your bank account right instantly. But think think in this particular way. If you by heart this 248 sentences, Girna Shreya, Denavashri, Trastunamyaha, etc., and now you are memorized this 248 vakyas, and suddenly somebody comes and asks you, hey, what is the longitude or the position of the moon on 124th day? So what you can do is you can just repeat those vakyas, Girna Shreya, Denavashri, Rudrastunamyaha, then suddenly at 124th line you will come up with Rama Giyate, and Rama Giyate represents the number 6, 13, 52, which is nothing but 6 rashis, 13 degrees, 52 minutes. Okay, you can just reproduce the vakya and just get the number out of it and reproduce. Yeah, so that's one of the beauties of this kind of way of representing.
Thank you very much, Dr. Pai. Thank you so very much indeed. It seems that all the queries of our colleagues, our attendees have been put to rest with your such a wonderful deliberations. And one quick question to you, Dr. Pai. Would you like to throw some light on some of the existing projects which are being undertaken? Because we have the knowledge of the past that we are able to rediscover now. And in your viewpoint, how do we envisage to deploy this knowledge of the past for shaping the future? That's a tagline that we have for our series, and this is a question I would like to ask you that that in your viewpoint, how do you foresee that that the wisdom of the past is going to shape the future of mathematics and astronomy and its applications wherever in any fields of knowledge or in any fields that is being applicable? How do you foresee that? Yes.
Okay. See, as far as mathematical and astronomical texts or the tradition is concerned, so most of these texts are still lying in the form of manuscripts in different manuscript libraries. And out of say, the people have estimated around 1 lakh manuscripts in scientific tradition, and out of which at least thousands of manuscripts are still in the manuscript form. Nobody has read it. Okay, in especially only in astronomy and mathematics. Out of this thousands of manuscripts, only 50 have been, only 50, 2 digits number, have been edited, translated, and critically studied by the scholars. So now, whatever I have discussed here is based on that very minimal studies done by previous scholars, or done by our group, or the previous, or our peers. Okay, still there are lot and minor and major manuscripts which are yet to be studied. Some manuscripts have been studied wrongly also, because here in order to read these manuscripts we need to have the knowledge of ancient scripts. Different, it may be in Devanagari, it may be in Nandinagari, and if you go to Kashmir you have Sharada script, and and if you go to south you have Grantha, then Nandinagari and Tiglari and Malayalam and so on. So one needs to know the script, then language in which these texts are composed, and then the subject, whether it's astronomy and maths, and then you have to understand, decipher this, and come up with the critical notes and critical editions. Yeah, so
thank you very much,
very
Dr.
small,
for
10% of work have been done till now. So yeah.
We have to collaboratively move and work together for this. So thank you very much, Dr. Pai, on behalf of DELNET, on behalf of each one of us. Thank you so very much for such an enlightening presentation, and for bringing it to light, the ignorant minds, how ignorant after listening to you, we have now realized how ignorant. We have been citing the big names, we have been citing the very, our Indian knowledge gurus, but we have not been really knowing, to the extent that what you have been able to make us all discuss yes, what ultimately, what was their actual contribution, and there has been such a great amount of, I must say that you have also ignited not much of curiosity now in each one of us, to know more about it, yes, and thank you so very much for really making it such a very memorable talk, and then memorable, and also at the same time, I must say, because this is the beginning of our very first inaugural session that you have been able to deliver this talk, and this is to share to all our colleagues that DELNET, we are really keen enough that every month to have one aspect of our Indian knowledge systems, one particular subject, to try to deliberate on. So we intend to come back every month with one webinar lecture under our series of IKS, bringing in the vast experts and their expertise, and having this forum for sharing, the vast knowledge. And we really look forward also to having your collaboration and cooperation in that. So may I now request Dr. Pai to you to accept this a small token.
Oh, thank
It's a small moment of gratitude to you for being there with us and for making the session such a truly an enlightening session. We remain ever grateful, and we'll be really, really happy if this takes a position somewhere. And we really look forward also to working with you, and to see to it that in days to come, we also create some good knowledge resource on our Indian knowledge systems. And also that is one of our area in which we are very keen enough that we should be able to bring in lot many of these unanswered questions into this platform, and having these deliberations, capturing it, and preserving the past for the future. That remains as one of the very strongest desire of DELNET, to capture our traditional knowledge and to contribute, to this entire effort of, for the current and for the future generations. So thank you very much, Dr. Pai, once again on behalf of each one of us, and you have been so many kind and gracious. Thank you very much for giving so much of your time. We remain truly grateful to you. We also would like to thank all our colleagues who have been able to join us from different nooks and parts of India, and also from many other countries. Thank you so very much for being getting into such an engaging conversations, and making it possible for us to have this very first inaugural session. This is just quickly to tell you all that on 12th of August, DELNET and CPF, we are holding a one-day seminar on cyber resilience and AI safety. I request you, it's a one-day entire seminar. Those of you who may like to join us in person at DELNET New Delhi, you are most welcome to drop us an email. You will be getting, and also there is the entire deliberations will be webcasted on the Zoom. So we request you, once you receive the certificate in another 1 hour's time, digital certificate, please do have a look at the content of the email, because it will be carrying the links for online as well as for in person if you want to come. We request you also do mark your calendars for October 8th. This is quite in advance. We are informing you about it. 8th of October at 8 o'clock, 8 p.m. IST, Indian Standard Time, we are going to have a DELNET annual lecture, which is entitled Openness as a Design Principle for AI as Infrastructure. And this is going to be delivered by Dr. Sayed Chaudhary, who is a special chair of AI at Carnegie Mellon University in US. And requesting you, please do keep your calendars marked for it, 8th October, 8 o'clock, and then on 12th of August we are having, and we really look forward to coming back again, announcing our next program under the IKS webinar series, and we are strongly feeling that, because we had asked our colleagues across the country what are the subjects, and we can see all of you are more interested in Ayurveda and health sciences. So we intend to hold the next month's program under the IKS series on Ayurveda. We will be notifying you. Also, we do notify, this is to request you all, we do mention about our upcoming programs on DELNET's website under the latest programs, that you can always have a look at it, and you are most welcome. You are most welcome to contact us any point of time. Has been a great honor and pleasure in organizing the very first session, and all our special admiration to Dr. Pai for delivering truly a scintillating, session today. And this has set the tone for this entire webinar series. We remain ever grateful to you, Dr. Pai. Thank you very much once again to you. And thank you very much, each one of you. And my very special thanks to my two colleagues, very dedicated colleagues who are working tirelessly for our webinar series. And Mr. Kushal Giri Goswami, Senior Network Assistant, and Mrs. Ranjana, who have really been of very consistent support. Thank you very much, both of you, and thank you very much, each one of you, for making our programs very special with your presence. Thank you very much, Dr. Pai. Looking forward to having more deliberations with you.
Thank you so much. Thank you so much for giving me inaugural session, inaugurating.
Pleasure entirely. Yeah. Thank you so much. Thank you, one and all. God bless you all. Do stay connected, and we really look forward to having you back in the future webinars. A very good evening to all of you. Thank you so very much. Thank you. Thank you.